Hello students, today I am explaining in friction, rough inclined surface. See this diagram, rough inclined surface. In this diagram, theta is angle of inclination. So at particular angle of incident, so the block which is placed on the rough inclined surface, just ready to slide down. That particular angle is called angle of inclination. This angle of inclination denoted by alpha. Now one body placed on this rough inclined surface. Now I'm resolving the weight of the body into two components. So this is weight mg. If mg makes an angle theta here, this is the horizontal component, which is mg cos theta, and this is normal force n, and this is mg sin theta because it is perpendicular to mg cos theta. Mg sin theta. Now the motion of the block is opposing by the frictional force F. F is the frictional force which is opposing the motion of the block, which is developing between the block and the frictional surface. Now, how much net force acting on the block, because block moving downward direction on the inclined surface. So net force acting on the block, this F net is equal to mg sin theta, which is acting downward direction, mg sin theta minus frictional force F. But F not nothing but mass into acceleration, ma is equal to, so mg sin theta minus frictional force F is equal to mu into n. But here block overcomes static friction, then coefficient of kinetic friction acting here. Then from diagram here, this normal force n balancing by mg cos theta. So n is equal to mg cos theta. Now see from last equation, mass into acceleration ma is equal to mg sin theta minus mu k into n value mg cos theta. Now from this equation, right side we can take common m, then ma is equal to m common, then this is g sin theta minus mu k cos theta. Both sides we can cancel m and m. Now finally the acceleration of the block which is placed on the rough inclined surface, a is equal to, so this is g sin theta. So g sin theta minus mu k cos theta. G into sin theta minus mu k cos theta. This is the acceleration of the block which is placed on the rough inclined surface. Now from same diagram I'm calculating more two values. One is velocity of the block, which is so if suppose if the length of the inclined surface is L, when block is placed on the top of inclined surface, initial velocity 0. Now after overcoming friction, the block reaches to bottom level with certain velocity. That velocity I'm calculating now. Velocity of block. But we know in kinematics, v square minus u square is equal to 2as. From this equation, v square minus u square is equal to 2as. Now v is the final velocity. We have to calculate this value minus initial velocity 0, which is equal to 2. And first I'm writing here s value. S is the length of inclined surface. Already I told length of inclined surface is L into A. Therefore, from this v is equal to 2LA under root. Now, if substituting this A value here, that velocity v is equal to 2L, A value g into sin theta minus mu k cos theta under root. This is the velocity of the body. Similarly, time taken by the block to reach from top of inclined surface to bottom level. Time. Now I'm using same kinematic relations. S is equal to ut plus half at square from S is equal to ut plus half into at square. S is length of inclined surface, which is L, is equal to initial velocity 0, 0 into t0 plus half into a into t square. From this, time t is equal to, so 2L divided by a under root. So if substituting again a value in this equation, that time t is equal to 2L divided by a value g into sine theta minus mu k cos theta under root. This is a time taken. So in this rough inclined surface, three values we calculated here: acceleration of the block, with what velocity block reaches to bottom level, and how much time taken by the block to reach from top of inclined surface to bottom level. Now, in case of smooth inclined surface, just coefficient of friction we can take 0, because so this frictional value negligible. So smooth inclined surface, so first directly I'm substituting here. Frictional force negligible, then coefficient of friction mu k 0. If substituting in these three equations, first one I'm writing acceleration, A is equal to g into sine theta, and the second equation, velocity V is equal to, so 2Lg into sine theta under, and the third equation, time taken t is equal to, so 2L divided by g sine theta under root. These three equations in the smooth inclined surface.